Did Albert Einstein predict correctly? Did Albert Einstein have it right when he predicted that we would never be able to see the farthest reaches of the universe? The James Webb Space Telescope, JWST, has now observed a void in the very early universe that could confirm this prediction. But what are we actually seeing here? Is it really a void, and could it be the beginning of the universe? Scientists may have just discovered a shocking fact. A strange void at the dawn of time could now confirm one of Albert Einstein's remarkable predictions. If we go back 100 years, scientists had slowly begun to look beyond the edges of the Milky Way. What they saw initially astounded them. At first, these were just hazy nebulae, but soon it became clear that these nebulae were actually other galaxies. The small and large Magellanic Clouds became visible, followed by the Andromeda Galaxy, and scientists were shocked to realize just how many other galaxies there were. Based on these discoveries, ideas about the evolution of galaxies and the infinity of the universe emerged. Then, Edwin Hubble observed that distant cosmic systems were moving away from us, and the idea of cosmic expansion was born. Shortly thereafter, the Belgian scientist Georges Lemaitre proposed the theory of a Big Bang, which took place around the time that Albert Einstein presented his theory of relativity. Many of Einstein's purely theoretical predictions made in the 1910s and 1920s have since been confirmed as cornerstones of modern science. Yet, despite all these breakthroughs, Einstein was not entirely convinced that the universe actually had a beginning and an end. Although he fundamentally accepted the Big Bang theory, he remained certain about one thing: we would never be able to observe that beginning or end, no matter how powerful our telescopes became. Why did Einstein believe this? There were two main reasons. First, the Big Bang theory and other related theories proposed that there was no light for hundreds of thousands of years immediately after the event. Today, scientists refer to this period as the Dark Ages. So how could we possibly see a moment in time, or an event, with telescopes when there was no light at all? Even today, exciting answers exist to this question, like with radio telescopes, which don't see but hear. However, researchers are fairly sure that the Big Bang wasn't a noisy event but took place in complete silence. In fact, space itself, where a detectable explosion could have occurred, didn't even exist at the moment of the Big Bang. Space itself only emerged after the Big Bang, and was formed as a result of this event. Radio telescopes detect waves that are generally far from the audible sound waves we experience. Space barely contains any sound. Only a few other waves penetrate interstellar space and can be made audible through modern advancements. So, we could not have heard the silent beginning of the universe. We discovered cosmic microwave background (CMB) radiation in the 1960s and have since mapped it well. This radiation is considered a secondary effect of the Big Bang, and much evidence for the Big Bang has been derived from it. However, the CMB, with its tiny wavelengths, has never led us directly to the Big Bang itself. Again, there seems to be no way to directly detect or prove the absolute beginning or the Big Bang. Einstein also had a second reason for believing that we would never be able to see the beginning or the edge of the universe. He thought that, due to the ongoing expansion of the universe, the point of origin would keep moving farther and farther away from us and would thus be out of our sight. This is a key aspect of his thinking. Albert Einstein also sometimes believed in a curvature of space, meaning that the origin point might be hidden behind some kind of horizon that would forever obscure our view. This was a time when the best telescopes could barely resolve the nearby galaxies. Today, we know about millions of galaxies in a universe teeming with expanding galaxies, and the universe is getting bigger all the time. Given the vast distances between galaxies and galaxy clusters, it is now possible for us to see as far as 13.6 billion light-years away with our telescopes, which brings us very close to the Big Bang. With the James Webb Space Telescope, we are now much closer than ever before. However, the JWST does not show us what scientists have called the Big Bang. 100 years ago, the JWST discovered a strange void. You've probably heard about it. The JWST found an incredibly high number of very ancient galaxies, some of which challenge the Big Bang theory. But did you also know that the JWST discovered a strange void, which could confirm Albert Einstein's prediction about the impossibility of observing the universe's beginning? Absolute voids are mysterious regions of the universe that are so empty they actually contradict the theory of relativity. But how does this void seem to confirm Einstein's ideas about the invisibility of the beginning? This is explained by the fact that scientists once thought these voids were a sign of the Dark Ages when there was no light, at least no stars or galaxies. Some researchers even believe that this discovery confirmed the existence of this early era. But then, the surprise came. The darkness turned out to be a vast void located extremely far away. We are also aware of more recent voids, which already pose scientific puzzles. However, in the extremely early universe, such voids are considered scientific impossibilities. They don't fit with the idea of the universe's homogeneity, which is directly tied to the Big Bang theory and the concept of cosmic expansion. These voids are too large and too strange. They have an inhomogeneous character and contradict some of the fundamental principles of our cosmology. So, does a void truly confirm Einstein's prediction? Not exactly. However, the JWST does seem to confirm Einstein's brilliant scientific viewpoint in another way. So far, the telescope has not found any evidence of a beginning or an early stage of the universe. The images of the supposedly very early universe show only structures and galaxies that don't appear very different from what we can observe in the present-day universe. A void, could it have been the origin of the universe? The question now is whether a mysterious void could have been the origin of the universe. We cannot completely rule out this hypothesis because, in the end, we will never truly know what voids are. Today, we must also admit that we do not fully understand them. This translation incorporates punctuation, grammar, and coherence while preserving the original ideas. The content reflects a complex subject about Einstein's predictions, the Big Bang, and the role of the James Webb Space Telescope in testing our understanding of the universe's origins. As a remark, the universe really began. The voids are probably empty, but we are not entirely sure. It is conceivable that they contain some kind of matter that we do not yet know. Imagine dark worlds. The voids are sometimes interpreted as kinds of parallel worlds, and some scientists consider them to be scar tissue resulting from the impact of universes in the multiverse. Other theories even claim that extraterrestrials have darkened these worlds in a void to harvest energy. You can already see that these mysterious voids challenge scientists and give rise to some of the wildest theories. Of course, it could be that our universe was created in a great void. The mere fact that we cannot prove otherwise strengthens such an idea. So the question remains, how was matter created, and what are singularities really? We have already discussed the nothingness from which the universe would have emerged. If it were the absolute starting point, how could we observe it? After all, it was nothing, and therefore undetectable to us. A singularity is a point where all the forces are either so condensed that our concepts of value and size fail, or where everything that exists is concentrated in that single point. This point was made up of a fluctuation of possibilities that existed in a state of complete equilibrium. It is said that some unknown event disturbed the status quo at a given moment, and creation began. It was from this brief moment that what we know and see today came into being. This means that, neither more nor less, all the information for you and me, all life on this earth, every star, and every exoplanet was contained in that minute point of nothingness. The question of how an infinitely small point could contain all this is one of the greatest mysteries of science and is currently unresolved. It is uncertain whether we will ever be able to solve this riddle. We find these mysterious singularities in another part of the universe, namely at the center of black holes. These black holes are located at the center of almost every known galaxy, and black holes are what remain when stars of a certain size explode. At least that's what scientists assume. No one has ever been to the center of a black hole, and as we've just seen, we have practically no way of knowing the absolute starting point of the universe, if it ever existed. This is based on calculations that made sense until the James Webb Telescope discovered something different from what our theories predicted. The Webb Telescope shows that the universe must be much older than we assumed, or that its nature is very different from what all our calculations predicted. Black holes are also one of the greatest mysteries in cosmology. They are enormous, very heavy, and all the forces they contain likely increase to infinity, so we have no way of actually exploring this infinite point that merges with the singularity using conventional methods. All hopes are currently placed in new supercomputers that, using their own algorithms, can decode the secrets of the universe and show us the real connections to this realm. Scientists are now turning to the intelligence of quantum particles, which are thought to be the universal stores of information. Meanwhile, Other advancements rely on the water's storage capacity to generate unusual computing power.